So yeah, once again, welcome to functions. Again, mixed graphs revision. Very, very important section. The last time we looked at a lot of mixed graphs. Some of you enjoyed certain parts of that. Some of you found certain parts difficult. And this is why I'm very curious to know how you're going to rank the graphs. Which one is your favorite and which one do you still find a bit difficult and is your least favorite? Let's have a look. Lots of different answers here. So obviously, there's some of you do like certain ones and some of you don't like certain ones. Okay, so Marilyn likes the parabola. That's Marilyn's favorite. We've got Mello. Mello really likes the straight line. And then on Tatile, also straight line. Jolene, also straight line. Straight line is quite a nice one. It's quite simple. You've done it for many grades. Yeah, I would say my favorite, if I had to choose, would be the straight line because it's a very simple one and not much complications. Um, so the straight line for a lot of you is the easiest graph or your favorite. Let's wait for two more people. Anybody else want to share? What about you, Kiabetswe or Luki? Melo? Sisanda? What about you? What are your favorite graphs and what is your less favorite ones? Luki likes parabola and Matlokonolo likes the parabola. Asamatle, you like the exponential first. Sure. Yeah, that is a bit of a challenging one. So it's really great that you like that one because it means that when you get to those difficult questions, you'll be able to understand it well. Thank you so much for that. Yeah, we're going to go straight into a question. And like I told you the last time, we did lots of different graphs over the past few weeks. And today is your turn to do a lot of the hard work and to share your answers with me. So I'm going to share a question with you. Please feel free to ask questions and let me know if you have any questions because this section is very important with a lot of marks and it can be challenging as well, right? So yeah, the last time we looked at some hyperbolas, some exponential graphs. Today I've decided to bring in some parabola and also straight line, just so we can get some variety. So I'm going to share this with you. Wait, I need to move it there. There we go. Okay, so I'm going to first expand this out like this. It says here, the diagram below shows the graph. There we go. There we go. Okay. The diagram below shows the graphs of fx equals minus x squared plus 2x plus 15 and gx equals minus 3x plus k. Which two graphs do we have here? If you want to unmute, you're welcome to just shout out the answer as well. Which two graphs do we have here? Or you can also type your answers. Which two graphs do we have here? Straight line and parabola. Yes. Thank you. So we've got a parabola and we've got a straight line. We've got here parabola. This one is parabola. And this one is straight line. Okay, so we've got two graphs, parabola and we've got straight line, right? Let's read further information. It says, graph F cuts the x-axis at A, which is -3 and 0, and B, which is 5 and 0. The y-axis at C, here we don't know the values though, and has a turning point at D. Graph G cuts the x-axis at B and the y-axis at C. E is a point on G such that DE is parallel to the y-axis. So I'm going to put in some parallel lines here. Parallel to the y-axis, right? Show that K equals 15. So they want us to show that K equals 15. And what is K? K emanates from the straight line. So the straight line equation, y equals minus 3x plus k, and k is here. In the place of k, which is the, you can tell me and calculate that, right? So we want to show that k equals 15. Please let me know when you get the answer. Then we can compare. K is 15. Let's see who's got an answer. Please, you can type in the chat. Just let me know that you have k equals 15, so I know if anybody has it. That will be really great. Who has the k value? You can just type there, I've got it. Okay, thanks, Sesetu. Well done. Montatile as well, well done. Let's wait for one more person. Who else has it? Okay, Maslochanola as well. Okay, so what we're going to do here, we're going to, how do we find this, right? Okay, we find it by taking the parabola and making the x equal to 0, right? Taking the parabola and making the x equal to 0. That's what we can do, right? Okay. So why is that? Because C, which is the y-intercept of the parabola, is also the y-intercept of the straight line. So let's make a note of that. So C here, C is the y-intercept of the parabola as well as the straight line. Y-intercept of both parabola and straight line. Okay, so we can find it from the parabola. We can say from the parabola y equals minus x squared plus 2x plus 15, and we make x equal to 0 to find c. So it's going to be y equals minus 0 squared plus 2 times 0 plus 15. So y equals 15. So at this point of c, y is 15. And we know then that k is equal to 15. Okay, any questions related to this? Any questions? Let's have a look in the chat. No? Got quite a few more people who have joined. Welcome, Valerie. Welcome, Samuel, Sade, Ronewa, Rabone, Dumiso. Okay. So, yeah, k equals 15. There's no questions related to this. Okay, let's move on then. The next one says, determine the coordinates of D, the turning point of F. They want to find D, the turning point of the parabola. So the equation of the parabola is, I'm going to write it here a bit bigger. So it is y equals minus x squared plus 2x plus 15. And we need to find D, the turning point of the parabola. So let's find that. What formula do we use to find the turning point of a parabola? Anybody? What formula do we use to find the turning point of a parabola? I know some of you did give it to me the last time. Yes?
X is equals to negative b divided by 2a.
Yes, well done. Okay, so that's to find D. We're going to say x equals minus b over 2a, right? Okay. And what is the value of b? What is the value of b? We've got here the equation is y equals minus x squared plus 2x plus 15, right? And then we've got here a x squared. This is the standard form of the equation. Ax squared plus bx plus c. So a equals minus 1, b equals 2, and c equals 15. Okay? And we can say to find the turning point, x equals minus b over 2a. So the b value is 2. So it's minus 2 over 2 times minus 1. So x equals 1. Is that right? Please help me to confirm. X equals 1. That's what I get here. X equals 1. Okay. Yes, that's correct. So some of you are saying, yes, that's correct. So it's x equals 1. Okay, great. And then we need to find y. So we're going to say y equals minus x squared plus 2x plus 15. And we're going to plug in the x in the place of the equation here, which is minus 1 squared plus 2 times 1 plus 15. So y will equal minus 1 plus 2 plus 15. So y equals 16. So the coordinates are 1 and 16. Okay, is that right, everybody? Are you comfortable with this question? Please let me know. You can type in the chat how you feeling about this question. Valerie, Marilyn, Samuel, how are you feeling about this? Sisanda? Okay, I've got a lot of thumbs up here. Adam, Denzel, thumbs up. That must mean that it's okay. You're understanding it. Okay. Jolene. Okay. You're feeling great. You understand. Okay. So since there's no questions, I'm going to assume that it's all okay. Determine the values of x for which f is increasing. Now, this is an interesting question. See what it says? It says, determine the values of x for which f is increasing. Determine the values of x for which f is increasing. I'm going to let you give me an answer for that. Let's try that, right? Here. For which f is increasing. And remember the point D was 1 and 16, right? So the values of x for which f, which is f is which equation? Oopsie. F is the parabola. There we go. So f is the parabola, and we need to find the values of x for which the parabola is increasing. Maybe somebody wants to take a try and let me know. You're welcome to unmute or type in the chat. Okay, I've got one answer here from Ontatile. X is an element of minus infinity up to 1. Who else has an answer? Who else has an answer? Roneva says X element of real numbers. So it can be any value. Hey, Roneva. Okay, I see no more answers. So the answer is, in fact, the answer provided by Ontatile. And why is that? I'm going to put the highlighter on here. And this is why. They want to know where x is increasing. So the value of x for which f is increasing. So here, the graph here increases, it goes up and then it stops here, see? At that point D, it's neither increasing nor decreasing, and then it goes down here, see? So here it's increasing, it's going up, and here it's decreasing, it's going down. So it's increasing from negative infinity up to 1, and then from 1 to positive infinity, it's decreasing. But it doesn't include 1, because at 1, it's neither increasing nor decreasing. Does this make sense? So the answer actually is minus infinity to 1. And we don't put square brackets, we put these brackets because it is not equal to neither of those, right? It's not equal to minus infinity because we don't know what infinity is, and it's not equal to 1. So it's between minus infinity to just before 1. So it's up to 1 and not including 1. And this is an element of, right? Okay. This is a difficult concept, so I'm sure there are questions. Does anybody want to maybe let me know if there are questions? Okay, let me just see if you can just provide me a thumbs up if you do understand this. If you understand it, can you maybe give me a thumbs up just so that I know that you're understanding it? Okay, we've got Jolene who's given me a thumbs up. We've got also Ronewa. Okay, Sipesihle. Okay, and then, okay. So Matlokonolo, you say you don't, not understanding. So let's go through that again. So 6.3 is they're finding the values of x for which f is increasing. So this graph here, if I show you here, a parabola, let's draw a parabola here. A parabola, it increases and it decreases. So if I've got a parabola here like this, and say I tell you this value here is x equals to 1. So at some point, it's going to be increasing. So here it goes up, see, it goes up. And here it goes down. So here we say when it goes up, we say it's increasing. And when it goes down, we say it's decreasing. So the graph is increasing from all this side here, all this side here, up to there. And then it's decreasing from all this here. So from negative infinity up to 1, it's increasing. And then from 1 to positive infinity, it's decreasing. Does that make sense? Let's ask Matlochanolo, is that fine? And then for your question also, Luki, when will you use the square bracket when a value is equal to something? We use a square bracket, right? When something is equal at that particular point, then we will use the square bracket. When it's not equal to, we use the open brackets there, right? The curved brackets. Okay, thanks for that, Sisanda. Matlochanolo, you must also let me know if it makes sense. Okay, then they say, this is what we did the last time, calculate the average gradient between A and D. So you should know this. So let's see what answers you get, right? Calculate the average gradient between A and D. So here's A and here's D. And I want you to calculate the average gradient, right? Calculate the average gradient between A and D. And what's the formula for that? It's y2 minus y1 over x2 minus x1, right? So if you can do that one for me, average gradient 6.4. Average gradient between A and D. Okay, I'm getting answers. So A, we've got minus 3 and 0. In D, we've got 1 and 16. Okay, so I'm going to say the gradient M equals to y2 minus y1 over x2 minus x1. So M is going to be change in y over change in x. So this is x1, y1 and x2, y2, right? So it's going to be 16 minus 0 over 1 minus 3. So the M, the gradient, will then be 16 over 4, which is 4. So the average gradient I found to be 4. I do see there are some different answers there. I'm just wondering how you got those different answers or whether you found if you made a mistake. Let's see. Yes, I got 4. Okay. A lot of you given me 4. Well done. Excellent. So the average gradient between A and D is indeed 4. Any questions regarding average gradient? Okay, thank you all. Thank you. Wow, lots of you. Antatile, Asamatle, Oratilwe, Luki, Sasetu, Valerie, Matlokonolo, Melo, and Sisanda. Well done. Thank you for sharing. And lastly, we want to find the length of DE. So that is a bit of a tricky one. The length of DE, yeah, maybe if you can find that for me, the length of DE. Here's DE on the graph, right? There's DE. Can you all see DE? That's DE, right? It's not very clear, that color. Let's use a different color. There, that's DE, right? Let's find the length of DE. So we know the X value there is 1. So how would we find D? We need to find the Y values of each of them, right? And then subtract it. So we need the Y value of the parabola, which we found to be 16. We need the Y value of that point E, and then we can minus. Because we know at point E, we also have 1, but we don't know what the Y value is. Let's see. Yeah, we've got the y value of the straight line, you'll need to find that. Then you can find the distance of DE. Anybody who's got the answer, please share so we can compare. At E, we've got there minus 3x plus 15, right? And in the place of x, we can plug in 1 to find y. So y equals minus 3 times 1 plus 15, which is 12. So we've got, this is 12. See, this point here is 12. The question mark is 12. And the top, we've got 16. So what will the distance be? 4 units. Thank you, Asamatle, for that. So it's 4, right? So DE is going to be 16 minus 12. Which is 4. Any questions related to this, to finding of DE? It is quite a challenging question, so, well, it requires some thought. So do let me know if you have any questions for that. Nope. Marilyn, you're saying you don't understand. So let's look at DE, right? I'm going to draw it here on the side. We have two graphs. We've got the parabola and we've got a straight line. Right? I should actually just use the line, but I hope I'm able to connect them nicely. Let's do this. Whoops. There. Ah, okay, there. Okay, that's it, right? And they want DE, right? So they want DE. So say I've got this, right? And I've got this point of x here, x equals to 1 at this point here. So here x equals 1, right? But for the parabola, y equals 16. So we know here, this point here is 16 here, see? Here it's 16, see? Now for the straight line, we've got the straight line equation, and we find when we plug in x equals to 1 that the y is 12 here, and they want this distance here. That's why we get it that it is 4. So we get 16 on the top, and then we've got 12 at the bottom, which is 4. Okay. So how do we get the y value of the straight line? We plug it into the equation of the straight line. So the equation of the straight line was y equals to minus 3x plus 15. And then we plugged in x equals to 1 in there to find the y. And then we plugged in x equals to 1 to find the y, which is 12. And that's how we got the y value of the straight line. So DE then gives us 4. Is that okay, everybody? Those of you that didn't understand. Look here, you don't just say units, you can just write 4, it's fine. But it would be nice if you can write 4 units. Okay, you understand. Okay, thank you for that, Marilyn, for that question. Okay, great. Yeah. Any further questions?
So
Yeah.
I use the distance formula from the analytical geometry. And I still
Okay,
got
you
the
got the same value, hey?
yes.
It's fine.
So it's
Not a
fine.
problem. Yeah, it's perfectly fine. I just a little bit longer, I don't know. Maybe it's easier, right? But yeah, it's a paper two formula, but it's okay. It's fine. You can use it. It's not a problem at all. Yeah, you're not gonna get marked down for that, right? As long as you get the same answer. Okay. So any further questions regarding this? No. Okay, I'm not seeing any questions here. Okay, great. Thank you for sharing. We're going to look at another one now. We've got another parabola here and we've got a hyperbola, right? The graphs of the functions fx equals to x squared plus 2x minus 4 and gx equals to minus 4 over x minus 4 are sketched below. B is the turning point of the f graph, right? Here, B is the turning point, right? Okay. The coordinates of B, the turning point of the parabola, that's what they want you to find. So let's try that. Let's find the coordinates of B, the turning point of the parabola. So if you can just find that out and just shout out your answer, that would be great. Let me know what is the answer. Who's going to give me the first answer? The turning point of the parabola. Boitumelo, Denzel, Jason, Sasetu, Tokozane, Sepang. Who's going to give me the value of the turning point of the parabola? Jolene. Okay, thank you, Oratilwe. So we're going to find it out by saying minus b over 2a, right? So we're going to say y equals x squared plus 2x minus 4. And we've got here that x equals minus b over 2a, which is minus 2 over 2 times 1, which is minus 1, right? So x equals minus 1. Plug into y equals so we're going to say y equals to minus 1 squared plus 2 times minus 1 minus 4, right? So then y equals to, yeah, we've got some people saying minus 5. Y equals to, yes, indeed, it equals minus 5. So the coordinates will be minus 1 and minus 5. Thank you for that. Find the x-intercept of G. Next question. find the x-intercept of G. So at the x-intercept, we may thank you so much for those answers. I see a lot of you are sharing those same answers. X-intercept y equals to 0 for G. So let's try that out. Okay, I've got some answers here. Okay, if somebody else wants to also share, I've got one answer. So I've got here, I'm working it out. Isn't this, yes, thank you, thank you. I've got lots of people sharing with it's -1. Or Atilwe, Mashokonolo, Asamahle, it is -1. It cannot be 16 because it's in the negative side, and it cannot be 0 because it's in the negative side, right? So it is indeed -1. And they want the x-intercept of that, right? Okay, any questions? No questions. Okay. And then, so that's -1, right? And then the range of f and the range of g. The range of f and the range of g. F is the parabola and g is the hyperbola. And remember here we had -1 and -5, right? So the range of f and the range of g. Anybody want to share? Range is y here. So for this one, the values must all be greater than this, right? See? Y, yes, thank you so much, Oratilwe. Y greater than -5 for this one here. Ooh, use that. Y greater than -5. Yes, that's the range of f. What about the range of g, the hyperbola? Who's going to share that the range of g, the hyperbola? What is the range of the hyperbola? Remember, we've got an asymptote here for the hyperbola, which is y equals -4 is the asymptote there, right? So what is the range of the hyperbola? Nobody wants to share. Let's look. Tokozane, Valerie, Melo, Ndumiso. Anybody wants to share? What is the range of the hyperbola? Okay, I'll share it with you. So it is y element of real, but y cannot equal to -4. So it's y element of real numbers, but y cannot equal to -4. So it can be any y value, but not -4, which is obvious because it is the asymptote at this point. So it cannot be this value here. See the minus. So it can be any y value but -4. Is that okay, everybody? Maybe you can just show me a thumbs up if that makes sense. Let's see. Is that okay? Okay, thank you for that. See, we've got some thumbs up. Okay, thank you for that. Thank you, Valerie. Thank you, Antatile or Tilwe. Okay. Okay, thank you, thank you. All right. Thank you, Luki. Okay, okay. Yeah, thanks, Ronewa. All right, so yeah, this is the range of the hyperbola, right? And the range of the parabola. Okay, so this is it from me for today. I'm going to hand you over to Nikela, but before that, I want to know if there's any parting questions before I leave. Any questions regarding these two questions? No. No. Anybody? Yes? No. Okay. So we've covered quite a lot, and this has you know, it's been really, really wonderful working with you for this section because we've covered a lot of different functions. And yeah, you're going to be heading into your next section very soon with Jennifer, and that will be your trigonometry. But Nikela will I'm sure, tell you more about that. And yeah, I look forward to meeting with you all again very soon. And thank you so much for contributing so well. And I really enjoyed working with you on this section. And study well. And I'm going to hand you over to Nikela.
Okay, hi guys. I just want to say well done to everyone. I think you guys, yeah, you guys have been so consistent. You put in so much work. You came to all the classes. I think, yeah, you really deserve a well done and a round of applause. I think you guys, yeah, did a really good job of making sure you understand everything. And yeah, it was really nice to have you guys in these lessons. So yeah, well done, guys. Um, I'm just going to go over, obviously, you see now we've just done lesson 8, which was our last one, the mixed graph revision. And just to recap, you can watch the recordings on the website and other people can watch the lives as well. Just take note of the website. Here is the URL. And for the homework, it's the same as last week. So because we finished the section, we just basically revising functions and relationships. And then you're going to do linear. Make sure you do the quizzes that are in these sections, parabola, hyperbola, and exponential functions. So make sure that you guys practice the quizzes. That's going to help you. It's going to be like your way of assessing where you are at. It's kind of like a mock test. So yeah, make sure you're doing that. Um, Also, our last session for the interactive workshops, our session 2, is going to be this Friday, which is tomorrow. So if you guys have been joining, feel free to, yes, come back. And if you haven't, and this is the first time you're hearing of this, you can still join us. It's not a problem. We have a little bit of a recap from the first one. So you can, yeah, just join us, even if you haven't been for the first one, that's fine. And before you leave, a quick reminder, we have a survey that we would really, really appreciate if you filled out. It really helps us to make sure that these classes are also benefiting you, and we can just keep them, yeah, in a way that we all are benefiting. And if there's things that are not working, maybe just let us know so we can keep improving our service for you guys and make sure you're getting what you need. So I have left the link in the chat. Maybe you can just copy the link and maybe just open it in the browser in the meanwhile before you leave. And then, yeah, your feedback is greatly appreciated. And just to let you know that, yeah, you guys are doing an amazing job. Thank you for attending all the lessons, and I hope to see you guys soon. So good luck for everything, and good luck if you're writing any tests or exams.